So now that you've watched a video, excuse me, that's introduced you to this idea of conditional statements and Boolean expressions, I also wanted to introduce you to the idea of a flowchart. So a flowchart is something that is used to help us design programs because a lot of times it's easier to think about the design of a program when we have a picture to look at. So this is a visual way of designing them. And there's some conventions that we kind of follow. Um, Whenever we have this idea of a Boolean expression where it's going to be true or false, and what the program is going to do depends on whether the expression is true or false, we're going to put the Boolean expression in a diamond, and then arrows that lead to what happens if it's true and what happens if it's false. So rectangles are going to be used kind of for anything that's not really a choice. But if we have a choice, it's going to be in a diamond in a flowchart. And this is a pretty standard way of drawing one. So I did want to show you some examples of what making a flowchart looks like. We'll start with some non-programming ones. But even though I'm still going to kind of explain them like they were programs. So can I go to the movies? I'm allowed to go if it's before 8 o'clock. So to do this, I first need to know what time is it. So I need to see what's the current time. Once I know the time, I can go to my decision making. So what I want to know is, since I would love to go to the movies, is the time before 8 o'clock? So in other words, is my time less than 8 o'clock? Because if it's before 8 o'clock, I have a time that's smaller than 8 o'clock, like 7 o'clock. Then I want to say, well, what happens if this is true? And what happens if this is false? Well, if the time is before 8 o'clock, I can go to the movies. But if the time is not before 8 o'clock, I can't go to the movies. And I know this is a pretty simplistic example, but these get more complicated as we start having more options of things that could happen. If I go to another one here, one that's a little bit more like what we would be designing in a program, have I won the game? I have if my score times my lives is greater than 10. So I first need to know my score, and I need to know how many lives I have. I can draw a better box than that. Once I know these things, I can go to my decision making. So my Boolean, well, I'm looking to see is the score times the lives greater than 10. Put that in diamond, and I want to see what happens when that's true and what happens when that is false. So if my score times lives is greater than 10, I can say I have won the game. But if my score times lives is not greater than 10, I have not yet won the game. Because it doesn't say I lost the game. It just says I haven't won it yet. And there would be a flowchart for how we would reach that decision visually. So kind of looking at this here, if I wanted to test this, let's say the score is 3. So if I have this is 3 and this is 3, those go into my diamond. It says let's figure out what score is times the number of lives. Well, that's 9. Is 9 greater than 10? That's false. So we have not won the game yet. But if I were to pick one of the other ones, if I had the score was 1 and the lives was 10, when I get into my decision box, the score would be 1 times the lives 10, which is 10. Is that greater than 10? No, it is not, so that's false. I have not won the game yet. But then, let's say my score was 12 and my lives was 2. I have 12 times 2, which is 24. Is that bigger than 10? That's true. I have won the game. I can also do mathematics within a Boolean expression. So if I was looking at, is my dog older than me if his age is converted to human years? And we'll go with the 7 dog years equals 1 human year. So there are actually 2 things I need to know for this. I need to know my dog's age, and I need to know my age. Once I know those, what I'm looking at is a Boolean where I look at, let's take the dog's age times 7, and I want to know if that's older, that means that would have to be greater than my age. If that's true, the dog is older. If that's false, the dog is not older. That does not automatically mean that I am older, because what if it ended up being the same number? So that's why I chose to put the dog is not older. We can then introduce complexity by introducing our compound Boolean expressions. We have ands and ors. These are just like the ands and ors you learned way back in geometry class when you were doing your logic units in geometry. So we have and statements, and kind of the shortcut here is the only way an and statement is true is if both parts of it are true. So here, if I have a true and a true, that's true. A true and a false, well, they're not both true, so the entire and statement is false. That'd be like saying it is sunny and the sky is purple. They're not both true, so the entire statement would be false. Same with this third example, and then if both parts are false, obviously the whole thing is false. Now what's going to be weird is that in JavaScript, we're going to be using the and when we want to talk about the and symbol. So we don't actually type the word and, we use the 2 ampersands. And when we see it, we typically just say and, although I have known some programmers that say and. We then have or. Or is these 2 vertical bars in JavaScript, so that's going to be our symbol for or. Or is kind of the reverse way of thinking from the ands. An and statement could only be true if everything in it is true. Well, an or statement can only be false if everything in it is false. If any part of an or statement is true, the entire or is true. So if both parts are true, the or statement is true. Here, if I have a true or false, that's still true because it's an or. I only need part of it to be true. If I have false or true, still true. But then false or false is the only time an or is false. We then have not. This typically comes up when we want to say not equal to, but we can say not greater than, we can say not less than. We can combine it with anything, any of our Boolean comparison operators. The idea of not is it just says do the opposite truth value. So if I have not true, well, if it's not true, it's false. And if it's not false, it's true. And when we want to use a not in JavaScript, we put an exclamation mark. So kind of seeing this in action is if I had, can I adopt a cat? I can if I have $40 and I'm over 14 years old. So there are 2 things I need to know. I need to know how much money I have, and I need to know my age. Those are going, now I can go to my decision diamond, and to adopt a cat, I need to know if I have $40. So I want to know if the money equals 40. Remember from the very first video, when I want to know is it equal to, I use the double equal signs. A single equal sign would be telling the computer, let's store 40 in the container money. So when I'm doing the Boolean and seeing does whatever money is equal 40 as a question, I use the double equals. And then this is an and in JavaScript, that's two ampersands. I need to know if my age is over or greater than 14. If this is true, I can adopt a cat. If this is false, I cannot adopt a cat. So hopefully this has been a decent introduction to trying to make some flowcharts. On the next page in OneNote, I'm going to ask you to attempt to make two flowcharts. These are harder than what I've shown in the video. I want you to give them a try. Please do not skip these. Please do not leave these blank. I want you to try them. Even if they're wrong, I need to see what you did, because this is going to be our jumping off point for what we do next class in person.